All right, so today we're going to end chapter 8. This is the last section we'll be talking about, which is kind of ironic because we've been dealing with content that really involves this topic up till now, but we're really going to formally discuss it and really what all the implications that it has. So let's switch over to the notes here. We're going to be talking about the normal distribution. And so I do want to emphasize that a lot of what we're going to be doing today is going to be focused utilizing this tool that's online. And I will tell you right now, for my online students, if you're worried about, hey, like, am I going to be able to access this through the exam? Yes, you can use this tool on your exam. That's fine. So again, feel free. It's a really useful tool. It calculates the density functions, which we'll talk about here in just a minute. So a normal distribution is a pattern that shows up pretty much all over the place. Test scores, people's weights, or even how long it takes to finish a puzzle, right? The middle of the bell, if you look at the normal distribution, it's like a standard bell curve is what it's referred to, kind of in layman's terms, because it looks kind of like a bell, right? You've got your bell curve, your standard bell curve. The middle of it is your mean. It's your the most of the data is going to fall right here on this mean in a standard normal distribution. You do have your high values are going to be really high up here, with being, pretty far away using multiple standard deviations. We talked about this last time with z-scores, right? So your z-scores are going to be z-score of 1, z-score of 2, z-score of 3, so on and so forth. This would be a -1, -2, -3. Each of these z-scores, or the distance away from the mean, there's a certain amount of data that fits inside of the bell curve. We call it a density function. And so it's really kind of cool, because what we can do is we can calculate probabilities of certain things happening, the likelihood of certain things happening based upon how well or where our data lives inside of this normal distribution. It's pretty cool. So all the statistical studies that we have, I shouldn't say all, many of them, they operate under the parameters or the understanding that the data is normally distributed, right? That on average, when you're looking at a population of people in sociological studies, medical studies, psychological studies, all kinds of stuff, when it involves studying people, that people, the way that they respond and work or behave, they operate on a normal curve. And so again, this is a lot of implications in how we do our scientific testing today. So some of the characteristics of that normal distribution, we have a graph symmetric about a vertical line through the mean. Okay, so again, there's symmetry to the left on this curve and to the right. The mean is going to be right where that symmetry lives. The y value of each point on the curve is the percent expressed as a decimal of the data at the corresponding x value. I'll go over a few examples illustrating what that means here in just a minute. And I think as we go through some examples, you'll begin to understand exactly like what this is referring to. The area under the curve that are symmetric about the mean are equal. So in other words, this 34% here and this 34% here are identical, exactly one standard deviation away, whether it's to the left or to the right. So again, on average, within one standard deviation, you've got 68% of the data, within 2, 95% of the data, and within 3, 99.7% of the data. Total area under the curve, there's a little bit beyond 3 standard deviations to the left and to the right, so that's that 0.3% remainder. And so the total area under the curve is 1, and that represents, a probability of 1, right? Probability of 1 is something certain to happen no matter what. And so if data is normally distributed, then all of it lives underneath that normal distribution. So I'm using a lot of terminology. And so I want you to, if it's kind of throwing you off, go back and listen to this again and try to look up the terms that are associated with it. You can actually access the textbook, which I'm actually going to look at today fairly substantially. But if you want, you can access the textbook in the Canvas shell. So if you scroll all the way to the top, you'll notice that there should be a link that says ebook right here, and that should open up the textbook for you. So I'd encourage you to go ahead and access that. There's tons of great examples. There's the process of, there's videos also in the textbook itself, the online textbook, for kind of walking through how to do some of this stuff, terminology. It's absolutely fantastic. Really encourage you to go and make use of that resource. So let me go back to, oh, it's funny, I wasn't even on my screen. Basically, this is what I was trying to show you, okay? Ebook, Discovering Mathematics, it's right here on the Canvas shell, so make sure you click that. Okay, let's go back. So I'm almost done with these notes, and then we'll go through some examples. Okay, actually, I already went through this. Let's just go through some examples. I think it's just going to be best for us at this point. So I'm actually going to pull up the textbook, and I want to go through some sample questions that are here. If you'll notice, the section I'm in is going to be 8.4, and you can actually find it by clicking these like 3 dots and going down to the section that we're on. There's a lot of information in here that's really great. So we'll do the preliminary exercises, okay? Actually, let's just go and do some of the actual exercises, section exercises. Some of them have answers, which is nice, so we can go ahead and check ourselves. What I'm going to do is we'll start off with this question here, question number 9. So you'll probably know that when we're working in a normal distribution, the 2 most important numbers that we have to deal with are the mean, which is that center line on the normal distribution, and we also need to have the standard deviation, because that will tell us essentially how like thin or thick our curve is going to be, how wide or narrow it will be. So those are 2 essential values that we need in order for us to determine some of these probabilities. And so, as I mentioned before, that link that's on the notes here at the very, very top, just click it open and you'll see the web page, which looks a lot like this. It's a normal distribution, and it's got a built-in calculator right here, okay? There are instructions in the section, if you read through the textbook, that will, like the online textbook, that will walk you through how to do it on a TI-84 and how to do it on Excel. To me, you can use that. It's up to you if you want. I don't really like how they explain utilizing the calculator, because there's a lot of guessing involved with that, which to me is kind of not the point, in my opinion. When you use this, there's no guessing. It will just tell you the answers when you put in the values, okay? And so that's part of the reason why I want to use this. You can just plug the values in that they give, and you'll be able to determine the solutions. So again, remember, this is density, a density curve. So the area underneath is representative of a percentage or a probability, okay? So let's take a look at question number 9. Cholesterol levels, specifically, the cholesterol levels of a group of students at a university are normally distributed, okay? Usually when you read scientific studies, it is crucial to understand the distribution of the population that they're studying, right? Or the sample group. If they do not believe that it's a normal distribution, there may be other distributions they're using, they need to specify it, okay? So as you pursue education, if anyone continues on to a 4-year school and you're reading statistical studies, make sure that they are indicating what distribution their population is that they're using. Okay. Normally distributed, this is crucial, with a mean of 185 and a standard deviation of 39. A mean of 185 and a standard deviation of 39. Okay, so what I'm going to do is I'm going to plop in 185 and 39 into the mean. 185 and 39 right here. I don't know if you can see that. Let me zoom in a little bit. There we go. Okay, 185 and 39. And the next thing that we have is the question, what percent? Okay, so remember, and I'm going to point this out as we work through these problems. Sometimes the question will ask you for a percentage, and sometimes the questions will ask you for a probability. Percentage means that you have to convert the probability into a percentage. If they're asking just purely for a probability, then it's just the decimal points. Okay, so just to make that distinguishment very clear. What percent of the students have a cholesterol level greater than 219? So what we're going to do is we're going to go over here, and you can see down below there's a few different possibilities. What we can do is we can look for above a certain value, below a certain value, between two values, or kind of the outside values. Okay. And the nice thing about this is that it will actually show you the graph. So we're looking for bigger than 219, right? So if I go above 219 and I click out of it, you'll see the curve fill in here where the 219 lives, which is down below. Everything that's above it, so it's indicating all the data that sits right here. And you'll notice the area is a probability. So listed right down here below, we've got the 0.1917. 0.1917. So since we're looking for a percentage greater than 219, this would be 19.17%. Or 19.2 in this instance. On the homework, you might have to kind of, depending on like how many decimals they're asking for. In this one, they really didn't specify, so you may have to just kind of use a couple of your opportunities to solve those problems and just see which one works. But in this instance, that tells us 19.2. So there it is. It's very nice. All right, let's look at the next part. Close this out. So we're going to look now between 190 and 225. So that's a between 190 and 225. I just punched these in here, 190 and 225. Tab out and take a look. It fills in the data right there, the bell curve right where our data lives between 190 and 225, and we get the probability, 29.65. Since the prior question gave us three significant digits, so one extra decimal point, I will make this 29.7, okay? Of course, seriously, they got to do that. Just play with it. In this instance, this is correct. Sometimes this is, I don't know why this does this, but you'll just have to be aware that the answer might be pretty close. And if you get to a point where you're like, I swear I'm putting the right answer in, but the system isn't taking it, just email me what question it is, and I will go back and I will correct those problems. Because obviously, like, there's going to be some slight discrepancies here, or there may be. So if there are slight discrepancies, but you're like, I swear I'm getting it right, just message me and I will take care of it, okay? So FYI. All right, let's go ahead and do another one. Let's jump to question number 13. Cereal weight. The weight of all boxes of cornflakes filled by a machine are normally distributed. Again, make sure when you're reading stuff that you are looking at the normal distribution. With a mean weight of 14.5 ounces and a standard deviation of 0.4 ounces. What's really interesting, just a little side note, the units don't really matter so much as the numbers you'll point that out, because in the previous one, right? No, question number 9, we were looking at cholesterol levels. Cholesterol levels and ounces of cereal weight really have no bearing or relationship with one another, right? So what matters is the consistency. So if I'm looking at the weight, right? If everything is in terms of weight, then that's all that matters. So 14.5 and 0.4. So this is going to turn into a 14.5. This is going to turn into a 0.4. And now what I have to do is figure out weight that is less than 14 ounces. Below 14 ounces. And like I said, I probably should have checked these to see that they match up with the homework, but I'm not. I'm kind of doing this on the fly, so you can get my instant reaction. Below 14 is going to be a 0.1056. So this is asking, again, for a percentage. So it should be 10 points. Is it going to be 0.6 or 0.5? I don't know. I guess we'll find out. 10.5 or 10.6? 10.6. There it is. In this case, they were correct. They rounded up. Will the next one be correct? I guess we'll find out. Between 13.5 ounces and 15.5. So this is going to be between 13.5 and what was it? 15.5? Yeah, 15.5. 15.5 ounces. Tab out. And that's a lot. It's a pretty big number. 98.8. 98.8%. There it is. Okay. So again, this is a really useful tool for just understanding the density, where all the data lives. Sorry, I got my brain deviated. I was thinking of Back to the Future, where he walks up to Lorraine and he was like, "You are my density." That's the density function here, okay? He was trying to say, "You are my destiny." But in any case, the normal distribution is my density. That is true. All right, let's do one more, and we'll call it quits on this video. This one does not have the questions or the solutions, so we'll just assume that my solutions are correct. That's a fun game. The mean snowfall in Vail, Colorado in January is 48 inches. Okay, so again, 48. But one thing that is not mentioned, this is again in the normal distribution section, but it is not mentioned that snowfall is a normal distribution. That is crucial. This is kind of a big issue with this question. So FYI, if they just give you these two numbers, but they don't tell you how the data is distributed, it's kind of bad. But again, because we're in the normal distribution section, 8.4, we'll just assume it's normal distribution. This is going to be 48 inches. 48. And the standard deviation is 8 inches. Okay, so we've got 3 parts here. What is the probability? So this is one of those questions that is asking us for the probability, not a percentage. So what that means is we are going to be putting in the decimal for our solution. If you look at the next question, number 19, the mean weight of an adult Great Dane dog is 170 pounds, a standard deviation of 15. What's the probability? This one I think is one that's on the homework assignment. So you can see kind of, that these are listed as decimals, whereas the ones prior, up here with serial weight, these were percentages. So just be aware of that. So this is actually going to be asking us for probabilities, so we don't actually have to make the conversion to a percentage. So we want to get more than 55 inches. So above 55. And our probability is going to be, in this case, 0.1908. We are not converting. I literally just said that. Man, my brain. Fun times. Okay. What is the probability that Vail will get more than 30 inches of snow in a given January? So we have more than 55 for the first part, more than 30 for the second part. So if you just notice, 30 is going to be down here on this curve. So it's a lot, like, it's going to be a fairly high number. So 30 inches, above 30 inches, 98, again, percentage, the probability, 0.9878. 0.988, something like that. Okay, 3 digits or 4 digits. I don't know exactly how far you want to go out, but a 98% chance. That's pretty high. That's a fairly high likelihood that Vail is going to get that much snow. All right. Last question. What's the probability that that's annoying. What's the probability that Vail will get between 45 and 57? Between 45, whoa, hello, 45 and 57. Boom. 51.59%, or 0.5159. There it is. There's our solution. Okay. All right, so that's really this section. Again, data is really crucial. I really would have preferred that these questions said that the data was normally distributed, but of course, you know, not every textbook is perfect. I might let the publisher know that that's a revision that they need to make. But in any case, that is really the section of content, and so that really is going to wrap up the section or the chapter on statistics. So if you do have any questions, don't hesitate to reach out. I would love to get back to you as soon as possible. So let me know. Have a good one.